Hey everyone, this is our lesson on percent yield, and by the end of this lesson you should be able to analyze the stoichiometric relationships inherent in a chemical reaction. But before you get started, you probably want to review limiting reagents, and you'll want to have that set of notes out to help you because I'm going to pull from the examples that we did in that set of notes for these examples. So percent yield is actually the easiest of the math that we're going to talk about in this unit. The only problem is sometimes you will have to use limiting reagent to help you with percent yield if I don't supply you with certain answers. But there are three terms to know when it comes to this calculation. The first one is theoretical yield, and this is the max amount of product that can be formed. So if you remember from the limiting reagent notes, this is what your limiting reagent will form. Once you run out of that, you can't make any more product, so that's the amount that will potentially form. Okay. The actual yield is what you would form in the lab. Okay, this value, especially on a test, is always going to be given. Now, if we're doing a lab and it's a percent yield lab and you actually have to calculate this out, you would use your numbers from what you form. But on a test, I can't expect you to just come up with a number. So I'll supply the actual yield for you. And then you use those to calculate percent yield, which is the percent of product formed based on the theoretical yield that you should have formed. And it's a very easy calculation. It's just actual over theoretical times 100. Remember, any percent is always part over whole times 100. Well, the whole value would be the theoretical because that's the max you could form, and the part would be the actual because that's what did form out of the reaction. And we're going to jump straight into some examples here. And we're using the notes from the examples from the last set of notes. So using the example in your limiting reagent notes, if 5.36 grams were formed of NH3, what's the percent yield? So we know we formed that. We want to know what the percent yield. And looking back at that equation, we know from the LR, which is our theoretical yield, we should have been able to form 6.07 grams of NH3. Okay, so knowing that, oh, sorry, my circle adjusted. Knowing that, let me shrink myself down because I have to lean in. I'm getting old. I have to lean in on my computer to write on it. So we know it's actual over theoretical times 100. We're in the same units because we solved for 6.07 grams. We solved for grams on the original problem, but that is something very important, and I'm going to just go ahead and click through this so you can see it. You've got to make sure your theoretical may not be given, so you'll have to solve for it, and make sure everything is in the same units. So we know it's A over T times 100. So my actual here is 5.36 grams. My theoretical was 6.07 grams. My grams cancel. We're going to multiply that by 100. So, clear, 5.36 divided by 6.07 times 100. So we actually formed right at 88% of percent yield. That's very high. For you guys, I usually like to say 85 or better is good. As you go into higher level sciences, one in particular I took was quantitative analysis. It was all about the amounts that you formed. If you got less than like 97%, you had to redo the lab. So for you, 80 to 85% or better is great. So this is a very good percent yield. So now I'm going to X out of my video here. I want you to pause the video and use your you do from the last example or last set of notes as well, and calculate what your percent yield would be. All right, guys. So